Hello students. In this video we are going to continue algebraic expressions part 4. In this part we are going to talk about reducing an algebraic expression, how to reduce an algebraic expression. To reduce an algebraic expression, first we collect or group like terms, and second, we add or subtract the coefficients of the like terms. To understand it better, let's solve some examples. Example 1, we have this algebraic expression. First step, we collect or group like terms. Here, if we notice, these three monomials are in fact like terms. They have different coefficients, but same variable with same degree. So first step, it's already done. They are grouped next to each other. Second step, we add or subtract the coefficients of the like terms. So here it's completely different than when we learned how to multiply monomials. Here we just add or subtract the coefficients, but the variable, it will stay the same. We don't add the exponents. We don't multiply the exponents. No, we copy x squared as it is. Let's solve it. So first, we need to group the coefficients of these three like terms next to each other. We have 5, -3, and +6. These are the three coefficients of these three like terms. Let's copy them next to each other. 5 minus 3 plus 6, we close the parentheses. Then x squared, the three monomials have x squared in them, so we write x squared as it is. We copy it. We don't add the degree, we don't add the exponent, we don't multiply them. No, we copy x squared as it is. Now we add or subtract the coefficients. So first we calculate the coefficients. We start 5 minus 3, it's 2. 2 plus 6, it's 8. And the variable with its degree, we copy it as it is. And the answer is 8x squared. Example 2. So first step, we collect or group like terms. We have here -2m squared n, +4m squared n, and -3m squared n are three like terms, and -5mn, it doesn't have a like term. After finding the like terms, we need to copy them next to each other. -2m squared n plus 4m squared n minus 3m squared n. We copy them with their sign. In the end, we copy -5mn. Next step, we need, as we did here, to group the coefficients of the like terms before we add or subtract them. So here we collected the like terms. Now let's continue. -2, +4, and -3 are the coefficients of these three like terms. We copy them next to each other. -2 plus 4, -3, and then we write m squared n. The same variable with the same degree. Of course, we don't multiply or add them. No, we copy one of them as it is. Then we copy -5mn. We copy it as it is. It doesn't have a like term. So in this step, we group the coefficients of the like terms, and last we add and subtract the coefficients of the like terms. -2 plus 4 is same as 4 minus 2. It's 2 minus 3, it's equal to -1. We put the sign of 3. Remark, if the coefficient is 1, we don't write it. So here we don't write -1m squared n. No, we only write -m squared n. If the coefficient is 1, we don't write it. Then we copy -5mn. This is the reduced form, the simplest form of this algebraic expression. we don't have like terms anymore. We cannot reduce it anymore. So in conclusion, when we reduce an algebraic expression, after grouping the like terms, we just add or subtract the coefficients of the like terms, and we copy the same variable with same degree of 1 of the like terms. We don't add or multiply the variables and their exponents. So in the end, we added or subtracted the coefficients of the like terms. Now let's continue with example 3. So first step, let's group the like terms. Here we have 3m and negative 5m. They are like terms. Negative 4am and positive 7am. They are like terms also. Positive 3x and negative 3x, they are like terms. But here we need to pay attention to something. If two like terms have opposite coefficients, it means their coefficients are opposite numbers, like positive 3 and negative 3, they are opposite numbers. If I add positive 3 and negative 3, they make 0. It means it's equal to 0x, it's 0. So in this case, we can cancel them, we cross them because they make a 0. And positive 2 is a constant. We don't have another constant here. So now let's group the like terms. 3m minus 5m minus 4am plus 7am plus 2. Now next step is to group the coefficients of the like terms. We have 3 and negative 5. Let's group them. 3 minus 5 between parentheses, and we copy the m. We don't do m times m or m plus m, no, we copy this m only. Then in this step, before we group the coefficients of negative 4am and positive 7am, before we group the negative 4 and positive 7, we write plus. Then we open the parentheses and we copy the coefficients negative 4 plus 7. Then we write am. So here we write plus always. It doesn't matter what is the sign of the coefficient of the next term. It doesn't matter. We always put plus. And the negative sign of the 4, we write it in between the parentheses. And the positive 2, we copy it. Now let's calculate 3 minus 5, it's negative 2, it's negative 2m. Now we copy the plus, and negative 4 plus 7, it's like 7 minus 4, it's a 3. So since it's positive number, we write the 3 without the parentheses. It's a 3am plus 2. And we obtain the simplest form, the reduced form of this algebraic expression. We don't have any like terms. Now example 4, here we have the constant negative 8. We have negative 1 and positive 3. We have negative 4x and negative 5x. They are like terms. And we have positive 9x squared. Now, before we group the like terms, a remark. Let's group the terms with the highest degree first and the constants last. So first, when you write these monomials again, start with the terms with highest degree. So we copy 9x squared first. Now we are going to group the terms who have x exponent 1 as a variable, after x exponent 2, x exponent 1, and in the end we group the constants. But before we do so, when we are going to group a negative 4x and negative 5x, we are going to skip this step. We are going to group these two like terms and their coefficients at the same time. And to do so, we write first plus. We open the parentheses, we copy the coefficient of negative 4x, it's negative 4, and the coefficient of negative 5x, it's negative 5. We close the parenthesis, then we write x. Then, before we group these three constants, we write plus again. We open the parenthesis, we write now negative 8, negative 1, and positive 3, and we close the parenthesis. So here we always write a plus. Even if the coefficient of this term has the minus sign, we write it between the parentheses, not outside. Now let's calculate the coefficients. We copy 9x squared, we copy the plus, negative 4, negative 5, it's negative 9. Since it's a negative number, we put it between parentheses, and we copy the x, we copy the plus, negative 8, negative 1, it's negative 9, negative 9 plus 3, it's negative 6. So we write negative 6 between parentheses because it's a negative number. Next step, we need to get rid of the parentheses and reduce it more. So first we copy 9x squared, and to reduce this expression we do plus times minus, it's minus, we obtain minus 9x, and plus times minus, it's minus 6. And this is the reduced form of this algebraic expression. So here we write the monomials with the highest degree first, and last we write the constants. Now let's continue with our final example, example 5. So let's start first. We need to find the like terms. Here we have negative 2 over 3 and exponent 4, and negative 1 over 2 and exponent 4. They are two like terms. We have positive 0.8 and cubed, negative 2 and cubed, and positive 1.2 and cubed. These are three like terms. Now let's group their coefficients directly without grouping the terms first. So we open the parentheses, we copy negative 2 over 3, then negative 1 over 2. We copy the coefficients of these two like terms. We write them between parentheses, then we copy an exponent 4. In this next step, we always write plus before we group the coefficients of these three like terms. We open the parentheses, we copy these three coefficients. We write 0.8, since it's positive, we don't write anything before it, negative 2, and plus 1.2. We copy the coefficients by writing the same sign that is preceded. So we don't change the signs, be careful. Then we copy and cubed. In the next step, we need to calculate what's between parentheses, the coefficient. Here we are subtracting two fractions with different denominator. Let's find the same denominator. It's of course 6. To obtain 6, we multiply 3 by 2. We do the same for the numerator, and we multiply 2 by 3. We do the same for the numerator. We obtain a negative 4 over 6 minus 3 over 6, and since we have here the same denominator, it won't change. We don't subtract the denominators. We can write it negative 4 minus 3 over 6. Then we write an exponent 4. We copy the plus. Now let's calculate this expression. 1.2 plus 0.8, it's 2. 2 minus 2, it's 0. So it's 0 between parentheses and cubed, equals negative 4, negative 3, it's negative 7 over 6. Since it's in the beginning of the expression, we don't have to write the parentheses. We write negative 7 over 6 and exponent 4 plus 0 and cubed. And 0 and cubed, it's 0. So the final answer is negative 7 over 6 and exponent 4. And this is the reduced form of this expression. So this is the end of this video. Do the examples by yourself on your own and check if you have or you obtain the same answer. Thank you for watching.